Hi everyone, thanks for joining. Can you hear me? Am I audible, guys? Can you hear me? Can you confirm if you can hear me? Hi, Salvador HS. Thanks for confirming. Anyone else? Can you hear me? If 3-4 people can confirm, we can move ahead. Can you confirm? Some more people, please. Then we can go and take some of the questions for today. Just thanks everyone who has joined. So this is a weekly live knowledge testing, knowledge sharing session where we bring some of the data science problems, some of the statistics, machine learning, mathematics, Python problems we try to discuss. Let me try to play in my phone. If you sometimes what happens is you guys send message and it does not come. So I will just try to see. Hello. Just give me a few minutes, guys. I'm just confirming that my connection is fine. Okay. Okay. So we will start. I'm believing you can hear me, and if you can't, then let me know through comment. Okay. So first question for today is this one, which we will take. Okay. So you have to tell me which of the measures of central tendency. Okay. So this is basically a statistics one. Which of the measures of central tendency will always change if a single value in the data changes? Okay. So you know what is measures of central tendency, right? So measures of central tendency is basically your mean, median, mode, right? So I will just start writing here also so that it's an interactive kind of session. So mean, median, and mode. Okay. So the question here is which of the below things will change even if you change one value in the data? So what's your answer for this? Even if you change one entry in the data, then that will change. Hello, thanks for joining. Who has joined now? Thanks for joining. So we are taking our first question here. Hi Jishan. Hello Jaychandran. Hello Jaychandra. SRD. Thanks for joining. So people are saying mean will change. Okay. So let's try to understand this with some examples. Okay. So mean affects more if any change. Salvador HS is saying mean will change. SRD is saying mean will change. So just we will try to understand with a small example. Let's say you have some data here, some numbers here. So let's say numbers are n1, n2, n3, n4, right? N4, and then let's say we have n numbers, right? N. So mean we will discuss in the end, but median is nothing but your middle data point, right? And if it's a even number of records, then you take two records, right? Two average of two records, two middle numbers basically. So what happens is only one number or two number will be your median. So it is not normally impacted by all the numbers. On the other hand, mode is basically your most occurring observation. So that also does not get impacted by all the numbers. But what is the definition of mean? Mean is nothing but you sum all these things and then divide by n, right? You sum all these things and then you divide by n. So even if one number changes, right, then your mean will change. So which of the central measure of central tendency will change? Mean will change even if you change one data point in your observation. Fine, simple one, everybody agrees with that. Let's move to the next one. So my question here is again from statistics, and you can answer it easily. If a positively skewed distribution has a median of 50, then which of the statement is true? Tell me from your understanding of positively and negatively skewed distribution. Hi, Daksh Bhatnagar. Thanks for joining. Yes, slight change also, but definitely mean will change, right? So little bit change also, but mean will change, but there is no guarantee that median and mode will change. So that's what we discussed. Now, some people might be confused between what is a negatively skewed, including me. I also get confused. Okay. So, I mean, just some people have that this is kind of, you can say positively. And if this happens on the other side, you can say negatively skewed. So what is the funda for positively skewed distribution? What is the funda for positively skewed distribution? The funda here is this line basically. For negatively skewed lines, mean, so for positively skewed lines, it will be other way around, right? So mean will be greater than 50 because more of the distribution are on the right side of the median. Okay. So here values are increasing. Okay. So you can, in one way, you can say that more numbers are greater than 50, which means mean will be greater than 50. So that is how you can say if it's a negatively distributed means more observations will be on this side. Okay. If more observations are on this side, then mean will be less than 50. Okay. SRD is giving one example for positively skewed are income of people. So one example is giving. Okay. So all of you understood this? Positive and let's say I'm not able to draw it very well, but still negative, more data point this side. Okay. Yes, very good examples coming. Let's see the third one, deep learning. What is adaptive moment estimation, or in short, ADAM? So you know that ADAM combines multiple things. For example, a stochastic gradient descent plus something else. What is that something else? You have to tell me. ADAM is a popular optimizer, right? So what makes the popular optimizer? I mean, ADAM is a combination of what all things that makes it a popular optimizer. Atom is a combination of momentum is one thing, obviously, and optimizer is the category of this actually. I mean, atom is one kind of optimizer. There can be one more optimizer. So my question here is, atom is special, atom is useful, as a atom is popular because it has a flavor of many things. One of that thing is momentum. What are other things? Yes, RMS prop also, right? RMS prop, Sherin has joined now. Good answer. RMS prop, right? So these two are basically main things that makes your optimizer atom a special optimizer, and that solves the problem of your vanishing gradient also. So we will have some discussions on vanishing gradient today in this session, because that is one important concept in deep learning space, right? So this was on deep learning, and we got the answer mostly. So atom is a combination of these two things, and uh, that makes it kind of one special optimizer. Okay. Now, yeah, learning rate also kind of with you can change it, right? This is a Python question, and somebody who is sitting with the compiler, maybe if you are not sitting with the compiler, you just tell me the pseudocode. Whoever watches this later, this video, try to do this. This is a question coming from one of the FANG interview only. Okay, so try to solve this. Okay, now if you can't do Python thing, try to think the pseudocode or logic. So the question is, create a function in Python that accepts two parameters. Okay, your function will take two parameters. They will both be numbers. Okay, the first will be a month as a number, and the second will be a 4-digit year. So your function should take two numbers, n1 and 2. Both will be numbers. Okay, so I will say here, and I will say, let's say I will say 21, and I will say 2001. Okay, month as a number, so it cannot be 21. Let's consider 2. Okay, 2, and the second one will be a 4-digit year. The function should pass the parameter return true if contains Friday the 13th. So if 13th is a Friday in that month, it should say yes, otherwise no. What should be the logic? Understood the question? Your question should take year and month. In that month, if there is a Friday 13th, say yes, otherwise no. What libraries you can use? Is there some Python library you can use here? I'm asking you this question because, as I told, this is a FANG interview question. Okay. Whoever joined now can just go ahead and press the like button. The idea is to develop the what to say, approach of solving a problem. Right or wrong answer is different story. Just think, how do you approach this, and what libraries packages can you use here? Do you know of a calendar library in Python? Rishabh is giving one idea, saying converting parameters to date using PD date time and extracting weekday can be one approach. Yes, but okay. So PD dot date time will take month and year, and it will give you kind of day. But how about the date? Day and date both can you get? I think both you can get. Any other approach? Any other approach, guys? So Rishabh is suggesting of using a package pd.datetime, or let's say datetime package, and you know pass these two things in the datetime and get the information on day and date also. My question to you is there an approach without using this library? Or any other library? No problem. If you can't think right now, you can think later as well. But this is just to have some mind running on various flavors of questions that can come your way. Okay, so we will go to the next one. So this is a theory question that can come your way. This is a common topic, many people have idea. Yes, there is a calendar module also we can use. What is a vanishing gradient problem? How it is different from exploiting gradient problem? This is a very common question from you can expect in deep learning interviews. So I want to have a very good answer from you guys on this. I'm sure you know this, but tell me, what is on top of your head when I say vanishing gradient or exploiting gradient? Sorry, exploding gradient. You can type it. This is not a Python coding. You can just simply type it. Yes, and see, you are just giving a definition. I mean, high level, but one should start from why this happens or what is the reason for this happening. So for example, if I have a limited number of iterations or limited epoch, will this problem come? Let's say one or two epoch only. Probably no. Then when this problem comes and how to, when we are discussing this, then also we should discuss how to take care of this problem, right? When weight of new is equal to weight of, Pranita is saying, when weight of new is equal to weight of old, is that a vanishing gradient problem? Choosing zero as initial random weight when large input is mapped to big one. No, not due to that. Vanishing gradient means basically your gradient will become very small. So it will, so let's say it starts from X value, then it will keep coming down, keep coming down, keep coming down, keep coming down, and it will become so small that it will vanish. That's why it is called vanishing gradient. Exploiting gradient is if you start from X, it will keep on increasing, 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 increasing. It will increase at a very significant rate and it will become very big, which is again of no use. Right? So that's what you guys are also saying. In chain rule, Rishabh is saying if more epochs, then ultimately weight tends to zero in vanishing gradient, obviously. So for both of these, more number of iterations or more epochs, that is the core reason for that. And when large input, Digvijay is saying when large input is mapped to small one, causing derivative to disappear. That is also one of the reason your derivatives disappear. The situation where weight are not getting updated by smaller values. Correct. That is what I'm saying. So when you reach end of this, it will become very small and it will become insignificant. So even if the increase is there, it is not very meaningful in vanishing gradient, or change is there, I should say. Exploiting gradient, it will become very big. Okay, how to overcome these problems? What are the solutions? Just a follow-up question on this. Do you know how can we kind of take care of these problems? We use ReLU optimizer normally. That's fine. ReLU is one thing that we can use, but that does not guarantee. Glow root is an optimizer, sorry, initializer, I believe, Daksh Bhatnagar. Initializer, choosing correct activation function, normalization. Yes, this is the answer which I like more. See, we cannot say that if we use a correct initializer, then it will go away. Or if we use a correct activation function, it will go away. Or if we initialize weight with something, then it will go away. Not like that. It is basically a combination of multiple things. We don't know, because deep learning is all about more data, more epochs, more iterations, right? We don't know. So it's again a try and test of all these combination. What Seren is saying, choosing correct activation function, normalization of weights, maybe initialization in different ways. So, but what we can see is, if this kind of problem comes, then how the model is behaving. If we know that, we can try out things. But in machine learning or deep learning, things are not guaranteed. Okay, so we know which direction we have to move, but not a guaranteed solution. Okay, so let's go to the next one. What is my next question here? This is a Python thing, and this is again, you can give me a pseudocode, or you can give me code also if you want. Write a Python function that accepts 2 string parameters. Again, somebody who is watching it later, you can try in Python compiler and comment me. Okay, the first parameter will be a string of character, and second parameter will be the same string of characters, but they will be in a different order and having one extra character. Okay, the function should return that extra character. So the number of, if for example, if I'm passing this as the first character, this as the second string, sorry, then the extra thing should be returned. So D is extra, so it should be returned. What would be the approach for this? I mean, better approach. So the lame approach will be to run a loop, take one by one, run a loop and compare with the entire thing. But what would be a better approach? Using pop. Okay, using pop, you will take one character and you will kind of search that in other one. Is that so? Or swap approach? Set functionalities. For set also you need to contains function, but contains will need a loop, I believe. Rishabh is saying convert to list and then compare the list. Okay, fine. It will be little faster than the basic looping approach, but there can be better approaches using set functionalities. Yes, I think it will be, if you see complexity wise, it will be same as list. Content function Vinay is saying, but contents means you will take one character and compare again, right? Okay, so again, there can be multiple approaches we can take, but end of it, we have to see, end of it, the end objective is to find one character which is not there. Okay, so if we can take one by one and compare with this by a fast mechanism, what would be a fast mechanism? So if we write a code by ourselves, right? For example, we write a loop or we write something from the scratch, that will always be slower than the system given, let's say functions or modules. Okay, so try to have more of system defined modules. For example, SRD is saying pop, right? So pop is, I would prefer pop more, because that is a Python thing and people would have taken care of data structures and heap consumption and space complexity, right? So So if something can help on that front, that should be given more preference. Okay. And if you talk of solving this problem, it can be solved in a number of ways. Yes, list comprehension, Daksh is saying that is same thing which Rishabh said. I mean, he will also convert it to a list and do a list comprehension kind of thing. Okay. So as I said, a number of ways to solve this, but try to use something which is offered by Python, and try to use something which is uh, try to, for these simple kind of problems, try not to write many lines of code by yourself. That is the one thumb rule I see as useful. Okay. And then your program should be faster, I believe. Okay. One simple question to all of you. What is this, true or false? Tell me. Standard deviation is robust to outliers. Standard deviation, right? Standard deviation is equal to, this is your mean line. Okay. Some of the observation will be above mean. Okay. Some of the observation will be below mean. Okay. In your data. So how you calculate standard deviation? This is your D1. This is your D2. This is your D3, right? This is your D4. This is your D5. You take distance of all the data points from the mean, right? And then you square it, sum it, and divide by number of observations. So if there is an outlier in the data, maybe here or maybe here, what will happen? Your distance from the mean will increase. Okay. Either you take this distance, let's say D6, or you take this distance, let's say D7. So if you have an outlier, this number is going to be big, which means your entire formula will get impacted. So standard deviation is robust to outlier, false. Okay, not true. Fine. All of you, I think, agree with me. So why I drew this picture is I found in one of the website this picture. This is very, very good picture to remember. Um, every time somebody asks you a question related to variance, I also ask to people in interview. I give you 10 numbers and I add 5 to all these numbers. Now tell me quickly, mean gets impacted, median gets impacted, standard deviation get impacted. What gets impacted and what does not get impacted? So if this picture is in your mind, right? Okay, this is a mean line. The guy is asking standard deviation, means he's talking about the distances from the mean. So you will be able to answer the questions related to measures of central tendency and measures of dispersion. Okay, so this is a useful image, hence I took some time to draw it. Okay, next is deep learning. Why can we not use sigmoid or 10H to activate the hidden layer of a neural network? Do you know this? So normally you will see that these kind of functions are less used in the hidden layer. So I'm sure you know the reason of this. When I asking robust means not getting much impacted, or you can, in simple language, you can say protected against. Okay, so the reason for this is because after this there is a puzzle and I want you to solve that puzzle. Okay, that's an interesting puzzle, try to solve that. But the reason for that is, if you see the mathematical function of sigmoid or mathematical function of 10H, right? Both of these will tend to promote your, what we discussed just now, exploding gradient and vanishing gradient problems. Okay, that is the main reason, and that problems happen in long, if your neural network is more layers. So from picture point of view, I'm thinking long neural network, right? More layers, more hidden layers, layer 1, layer 2, layer 3, layer 4, layer 5, more possibility of exploding gradient and vanishing gradient. And these functions, if you use right, then it will add it to more. If you see the mathematical formula, you will understand. Okay. Okay. So this is, here is a puzzle. I also don't know how to solve this. I will solve with you on only. Okay. So what it says, you are blindfolded and 10 coins are placed in front of you on a table. Okay. You are allowed to touch the coin, but can't tell which way up they are by feel. Okay. You are told that there are 5 coins heads up and 5 coins tails up, but not which ones are which. Can you make 2 piles of coin, each with the same number of heads up? You can flip the coin any number of times. I'm also thinking with you. I have taken it from some place. So you also think, I will also think. Okay. What it is saying, 10 coins. Okay. So let me draw 10 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 coins in front of me. I am blind. You are told to touch. I can touch. 5 each heads up. Okay. Can you make 2 piles of coin, which means 5, 5, 1. One pile will be 5, other pile will be 5. You can flip the coins as many number of times. Can you make 2 piles with the same number of heads up? Okay. So if I take first 5 coin and make a, let's say, pile. Okay. For example, 1, 2, 3, 4, 5. So what can happen is, this can be, let's say, for example, head, can be tail, this can be head, this can be tail, just a thought process. And let's say these 5 I took now. These 5 I took now, and these are the initial situation of these, right? So if I have taken, let's say, 1, 2, 3 heads, then obviously in this one there will be only 2 heads. Give me some idea, guys. So obviously this 5 will be reverse of this 5. No, not always true, right? Hmm. Same number of heads up. It's asking just same number of heads up, right? What happens if I flip all these ones? So here 3 heads. So here obviously there will be 2 heads in the remaining set, right? Remaining set में 2 heads will be there. Now if I flip it, then done, I think. Tail, head, tail, head, tail. Last one will be tail, right? So 2 heads here and 2 heads here. Done, right? What it is saying is you have to make 2 piles, 5, 5. Both of these should have same number of heads. So what my point is, any 5 coin you take, okay, and let's say remaining there are 3 heads or 4 heads, whatever heads. So you will have opposite of that here, right? So you take that and flip that, turn all the coins one time. Do you agree with this solution? You have any other idea? So I took the first 5, for example. Initial state is this HT, HTH. When I flip all these ones, it become TH, T, H, T. So 2 heads, 2 heads. Do you accept this answer or any other idea? Are you trying? Okay. I think some people are trying, but some people are not trying also. And it's getting little late because the time is almost close to 11 now, 10:45 like that. So I leave it to you. You guys take this question and solve it. And people who are watching, yeah. Same approach I also took. It's not a difficult question. I mean, see, there are many difficult puzzles, but the difficulty wise, it's not that difficult. Just that we have to understand the question and approach it. Online you got. I also got this question online. So what I will do is I will get some puzzles online. Okay. I will try to put it here because puzzles are interesting, right? So I also don't know the answer. So when we solve, it's fun. Okay. So what we did in today's session, guys, just a review. We did some basic statistics, some positive, negative skewed, some deep learning, some Python, some more statistics, some deep learning puzzle. So I hope you like the session, guys. I released a very nice video on, just now I released a video on system design. Many people are not taking that seriously, but believe me, if you are going for a Facebook, Microsoft, Amazon, Google interviews, you cannot ignore this topic, system design. Okay. Do not ignore this topic if you are going for any big short company. Okay. And I gave you one video just now 1 hour back, how to answer your questions on system design. Okay. Just watch that video. That will be very, very useful for you. Okay. And to all of you, if you want to refer my courses to any of your friends, brothers, sisters, there is a very good discount going on. Very, very good festival discount going on. They have to go to Unfold Data Science website and make a purchase. No need of any coupon codes, nothing. Just go make the purchase. Link is there on the description. And please give me a thumbs up if you like these sessions, and I should continue next Thursday as well. Thanks everyone for joining. SRD, Rishabh, Ajkar, Rishabh, Pranita, you guys are joining very regularly. So I'm very happy. Daksh is also joining regularly. Sherin is also joining regularly. Some more people are joining, but maybe it's a festival wala week, right? So some people are not able to join today. I'm sure they will watch later. Okay. So do you guys like this session? Thanks everyone for joining. It when it becomes interactive, then there is fun, right? Thanks Vinay, thanks Chardy, thanks Sherin. You guys are joining regularly. Thanks for that. We will continue this, and if you watch system design video, that will be useful for you, believe me. Okay, that it will come in 2 parts, part 1, part 2. Was that because what happens is sometimes you will get blank. I'm not saying that you don't have idea of system design. I'm saying you may get blank when somebody throws these questions to you. Okay, so just don't be in that state, and there is always a scope for improvement. Fine. Okay, so I will see you all guys in next video. Have a very nice rest of the evening. Okay, take care everyone. Bye bye.